All right, so example 4 is somewhat like example 3 was yesterday. We got this right triangle, we have the altitude drawn from the right angle up to the hypotenuse, and it cuts the hypotenuse into two pieces here, 9.6 and 5.4. With these corollaries we just looked at, it says RT, so we're trying to find this, so let's just call this X to give it a name. The three corollaries we learned were that let's say this is Y and this is Z, that Y squared equals the product of these two numbers. So if I needed to define Y, I'd have to say Y squared equals the product of these two, just take the square root. X, the piece we're looking for, equals the entire side here, RS, so the entire length of RS, which would be the sum of these two pieces, that'd be 15, times the piece closest to that side. Okay, this side squared would be the product of those two numbers. So if I use that corollary, X squared is equal to the entire side length of 15 times the piece closest to RT, which is 9.6. So again, that's how we're going to use the corollary to theorem 7.4. So again, it's this exact picture. We know these two pieces here. We can find any one of these three pieces very easily. Y squared equals this times this. X squared equals the entire length 15 times the piece closest. Z squared would be the entire length 15 times the piece closest. Again, they're asking for RT, so I'm using only that piece. My calculator evaluates, so 15 times 9.6 is equal to 144. If X squared equals 144, that means X equals 12. So RT is X, so RT equals 12 is the right answer to this problem. And they don't ask me for Y or Z, but again, just to apply this corollary to show you how it works, they did ask me for UT, this piece here, I'll circle it in purple. Y squared is simply the two pieces, the one in the middle here is just the product of these two pieces. So Y squared is going to be 9.6 times 5.4. So I'll get my calculator again, type in 9.6 times 5.4. So Y squared equals 51.84. So we take the square root of 51.84, and the calculator says the answer is 7.2. So Y squared equals 7.2, or Y equals 7.2, sorry. And Y is UT, so UT equals 7.2. If we wanted to find out what Z equals the entire thing, which again is 15, times the piece closest to Z, which is 5.4. So Z squared equals 15 times 5.4. And our calculator can calculate 15 times 5.4 equals 81. So Z squared is 81, that means Z equals 9, and Z is representing ST, so ST is 9. So it's just, for lack of a better name, there are little formulas there for that picture. And this happens quite often where we have this right triangle with the altitude drawn to the hypotenuse, and the hypotenuse is split into two equal pieces. So if you see this picture in general, it's very easy to find the missing pieces using these formulas.